And I saw opportunities to take things from other industries and apply it in terms of efficiency, digital ordering, et cetera, but I was getting resistance. Additive manufacturing was something that always had curiosity for me. It really seemed like a solution for the today and the future, rather than reacting to kind of the situation and doing things the same way. Kind of the two questions I had when I joined the business, the make it or break it, were one, can you handle industrial scale? The other was, is the material the same? And so we're doing parts right now in metal that we're testing at 200,000 plus PSI, and it's not breaking. It's actually breaking the test specimens. I have a lot of random stuff that breaks in the house. If I could just print a little jig for a kitchen sink or something, that would be awesome. Not everybody's a designer, not everybody's an engineer. So it's really that rise of open source designs, but I see it coming.
Welcome to Forging the Future. I'm Chris Howard, and today we have a very interesting guest who is transforming the future of manufacturing. Tim Neal, the CEO of AmPd's, a Houston-based additive manufacturing startup with over 15 years of experience in digital manufacturing. Welcome to the show.
Thank you for having me. Look forward to it.
So AmPd, is that a backronym?
It is. Additive manufacturing, product design.
Okay.
It's core to what we do.
Well, that's pretty cool. I mean, you're actually the founder yourself, right?
So this company, I'm two-time founder. This company, I'm the first CEO of the business.
Okay. So a partner brought you in to
Yes.
be CEO on AmPd, but you founded two other companies in the past?
Mm-hmm.
Okay. And what were those also in the manufacturing space?
Yeah, so it was, I kind of think of it as industry as a whole. It's a landscape with many steps. So I started my career in the manufacturing side. Then my startups before were on the distribution of products from manufacturers to end users. And this is kind of an ode back to the manufacturing roots.
Okay. Well, what really led you to lead this particular innovative venture?
So for me, having spent a long time on the distribution side, a bunch of things became apparent. There was a lot of supply chain inconsistencies. Boats, ports were all being held up. It was unreliable to maintain business by waiting on things. The other was we always had a hard time, especially with aging assets, on obsolescence of parts. And so the key is, how do you get ahead of that manufacturing strategy? So additive manufacturing was something that always had curiosity for me. I'd always, frankly, seen it as a hobbyist type market, which I think a lot of the world has historically seen it. But when I kind of walked into that company and did a lot more research on the industry, learning kind of the production scalability, the just-in-time nature, and the ability to recreate parts just by reverse engineering and taking 3D scans, it really seemed like a solution for the today and the future, rather than reacting to kind of the situation and doing things the same way.
Well, why do they call it additive manufacturing? What's the difference between that and like traditional manufacturing?
Yeah, so for traditional manufacturing, you're going to start with, say, steel. You're going to start with a steel bar, and you're basically subtracting out components or layers of steel. You're shaving it out to get a finished part. Additive manufacturing, we start with just powder. It's a blank canvas, and we build parts layer by layer, so it's additively creating a finished part rather than subtractively.
And so it's 3D printing? I mean,
3D printing, yeah, is a more common word for it.
But it's
the industry calls it additive. The world calls it 3D printing.
Well, because I think maybe most people think 3D printing as plastics.
Exactly.
Right? Extruded plastic stuff, where this is actually metal.
Yeah.
Is it similar, like the way the nozzle works? It's actually layering on metal?
Yeah, so we use a technology called metal binder jetting, and it really is very similar to an inkjet printer. Mm-hmm. So it's got a memjet print head, and it spreads layers, applies a binder where the parts are, and we'll basically go back and forth until you have a finished build box. And then on our plastics, that's more a light projection.
Is the strength of that steel part still as strong as like a part that you're going to carve out of a piece of steel?
Yeah, so that was kind of the two questions I had when I joined the business, the make it or break it. Were one, can you handle industrial scale? Or is this a 100 part type thing, right?
How many can you print? And
Exactly.
How fast?
How fast can you print it? So we're getting customer demands right now for 50,000 units a year of a part. We can print that. We can do one part, we can make 1,500 a week, another we can make 20,000 a week. So it can handle that volume and repeatability of that. The other was, is the material the same? This is coming out of powder, and basically you get a metal clay, and then you need to sinter it. So that was one of the big things. And so we're doing parts right now in metal that we're testing at 200,000 plus PSI, and it's not breaking. It's actually breaking the test specimens. And so it's outperforming. And with large manufacturers that we work with, Fortune 1000 companies, they'll run our products to their kind of main bar stock requirements, and we will meet or exceed all of those. So it's very much one for one, plus it's fully isotropic, so it adds increased value.
What's the resolution of the part? I mean, is it kind of rough part, or is it like, like in the past you had 75 DPI versus 600 DPI for printing or something like that?
Yeah, so what we get out of the furnace, just kind of finished part, in more technical terms, it's about 55 RA, so it's a good surface quality to it. I kind of like the look. It's more industrial feeling, kind of a grayish hue to it. But what we have a lot of customers, because of their applications, they need mirror finishes or others. And so we have a post-process where we can get it down to look exactly the same as a machine part.
So besides that, I mean, what about the cost differential? I mean, in the past, 3D printed parts were more expensive and took longer. I mean, it sounds like you're doing like tens of thousands at a time. Is it pretty economical?
Yeah, so there's kind of a couple ways to look at it. The first is, if it's a simple component that's easy to machine, probably doesn't make sense. Where we really thrive is complex geometries. We can do internal geometries, different shapes with high tolerances that aren't previously economical to do.
Using the other method.
Which is kind of CNC machining or injection molding. And so that's really one use case, is complex geometries. The other is where a lot of assembly is required. So we have a part that used to cost a customer $700 to make. That's because it's 5 components. They had 4 or 5 steps in terms of machining it, finishing it, wire EDMing, et cetera. We can print it all, because one of the nice things about the printers is we can print multiple products at one time, where a CNC can only machine one type of product. And so we can print those all together, where their cost went from hundreds of dollars to $100 a unit. So it really depends on the use case. The big one that we see as well, and more on the plastic side, is customers understanding total cost of ownership. So a lot of customers, when they're buying products overseas, they might be getting the product for 10 cents a unit, but they're only ordering 100 a year. A lot of their molds that they need for the injection molding is now becoming kind of obsolescent, that they need to make a CapEx investment. That might cost them $20,000 to make a mold. Well, if you're only making 100 units a year, your total cost per product is quite high. So you can spot manufacture these without needing a mold. And then if you look on a kind of unit economic basis, it's more effective for them.
Interesting. Yeah, so actually, even in, say, a proof of concept situation, or you build a limited number or a limited run, it used to be in the past you would do like an aluminum mold or even maybe a silicon mold or something like that, because you're not going to do a bunch of pressing, or you bite the bullet and do like a steel mold, but then if you don't end up doing many of them, then those parts became very expensive.
Exactly.
Can you print the parts like together, like even like assembled, or?
We can we print boxes that you can't take apart, because we print layer by layer, so you can just put voids. So basically you can make things that are impossible to disconnect because it's just, given the process, you're able to do that. The big thing that we see with customers a lot of times is, especially large manufacturers, their lead time for certain spare parts might be 6 months, 8 months, where if they just store their drawings, they can spot manufacture and have them delivered in 2-3 days. So it's really that reduction of total inventory, the availability to get them out of lost time situations as well.
Yeah, I imagine then what you're telling them from an ROI basis, you don't have to make the steel mold. That's the cost investment in that. You also have speed to manufacturing, right? Because you can do it quicker. You don't have to wait for the shipping to have it brought over on the boat, which of course then nowadays might even be delayed months
Exactly.
and months, maybe a year or whatever, some risk there, right? And add that all into the cost of that part.
Yep.
What's an example of like a recent part maybe that that you've done that?
Yeah, so we're
I'd be
doing,
familiar.
it's kind of a smorgasbord of parts. We're really across the board in industrial focuses. So we'll do things from Tabasco, for example. We make fixtures that hold Tabasco bottles in while they're going down the assembly plant. We'll make heat exchanger coils. So inside a heat exchanger, there's a metal, kind of like spaghetti noodle almost, things like that. Really components for large equipment assemblies. We're making some parts that go in space right now. But it's really that kind of, we live in a world under a softball size. If you have components, especially complex geometries, those are usually a really good fit.
Do you see like a world where we'd have our own personal printer then make parts like this, or is that pretty far off still?
I think we're getting there, especially with open source design availability that you can find. It will start as gimmicks. I printed at the shop the other day a little dinosaur for my daughter, right? That's fun. It gets the kids interested, especially with the rise of STEM and getting kids involved with technology. What I really want actually is, I have a lot of random stuff that breaks in the house. If I could just print a little jig for a kitchen sink or something, that would be awesome. But it will take, not everybody's a designer, not everybody's an engineer. So it's really that rise of open source designs. But I see it coming.
Having the CAD or the models in order to print that.
Yeah, and the cost basis is going down a lot. Industrial printers get very expensive. Mm-hmm. You can get a home printer now for $800.
That does, like what type of print? Plastic printing?
It's plastic print. It's an extrusion style, but it's good enough for a home application.
Well, we got our grandsons a toy maker printer a couple of years ago, and they still use it once in a while to make stuff or give gifts or make a part or make a toy. It's pretty interesting.
It's a super rewarding process too, because it's a tangible result.
Yeah, they love it. I mean, it's just the plastic, low res stuff, but you can see the potential of, wow, if this actually was a little bit more capable, there's a lot of things you could print at home.
Definitely.
That you needed. Well, what got you interested in this whole additive manufacturing process?
So it was really kind of curiosity around the technology. And then it was seeing that this can be done at industrial scale and kind of like we discussed about the obsolescence of part and really the need fit in the market. What also really interested me is the industry as a whole is very science forward. And they're always pushing the boundaries on what are design capabilities, what is new kind of materials that we can come out with, and what is the next kind of science project we can do around the space. I saw it from a different lens, which is the industry needs parts right now, and we can do it more economically. So let's find the use cases in today's industrial world that fit today's application. And as we educate the customers on the quality, on the kind of material performance, et cetera, then we're able to then, through this education process, move into more complex designs as they gain more familiarity. So it's kind of that gradual, just like how we went from, the flip phone to an iPhone.
Do you see this as becoming more of an industry here in the U.S., or is this what's happening now versus, traditionally manufacturing's been done offshore in places like China and Taiwan, right?
Yeah, so I see, if you look at kind of the projections of the industry, it's over the next 5 years, the CAGR on the industry is 27%. So it's a fast-growing market while still emerging. It's relatively small compared to traditional injection molding. What we're really seeing now is the shift in the tide, where people have felt the pain of product lead times, delays. The government's also very forward on this initiative about needing to reshore, and they're actually one of the leaders in terms of pushing additive into their production. And so we're seeing a big tidal shift in terms of moving things to the US. This is a great technology that addresses what engineers are capable of designing, but the machines couldn't traditionally make because of how they were built. And so I really see this emerging through the coming years. It's going to take education. I think what it'll also take, and we're spending a lot of time focused on it, is working with universities to train a workforce, because most people have never touched this technology. So creating trade schools and apprenticeships where people can learn, just like how they learn to be an electrician or a CNC machinist, this is a viable career for them.
Does it unlock other engineering possibilities? Because normally we build gears and other parts, but because of the process, you can make objects in a totally different way that has a different type of structure, right?
Exactly. It's reimagining what was possible, because before you could only design to what the machine could handle. We're dealing with a lot of parts such as gas nozzles where there's internal chambers so gas can flow certain ways, but really unlocks the ability to go inside a part and create more efficient designs, whether it's emissions efficiency or others. The other interesting thing is traditionally when you machine, you're subtracting and you're taking away metal from that. What we see though is you don't need all the metal, but people don't get to kind of that perfect part because the cost is based on time largely. And so you get these heavy parts that are machined. Since we're building layer by layer, we just made a part for a car that was 80 grams machined. Because we didn't need this external block on it, we got the weight down 60% with the same functionality. So it really helps lightweight, which then allows you to add more components to an assembly and increase efficiency.
Yeah, I've seen some parts that even look very organic, right? You know, because of the using nature as the key of how this would look. You wouldn't normally like press or form in the other traditional ways. But I'm just wondering if tools like SolidWorks and other things have taken additive manufacturing into account yet. Like what's possible?
They're starting to. What we're seeing right now in kind of the startup land is the emergence of generative design for additive, kind of unlocking that design freedom. And so I think that's going to be a fast emerging. It will take a little while, I think, for adoption because people are trained on SolidWorks and that's what they know, right, or a different CAD system. And so, but the wave's kind of moving that direction, especially with this younger wave of engineers who want to push kind of their engineering capabilities and design freedom.
So combining like even generative AI with an additive manufacturing model to create products that couldn't be made any other way.
Exactly.
That are actually lighter, faster, stronger, better than what you could do with traditional methods. I think that's super interesting. It's probably some wacky shapes too.
Yeah, they look funky, but they're efficient.
They work, yeah, interesting. So for someone that's maybe not as familiar about the manufacturing process, how does it work from maybe start to finish? If I have a need, I come to you guys, and you're going to help me get it created? Yeah,
so we believe in cradle to grave manufacturing, so that's kind of the full life cycle there. Typically, the kind of inbound will come one of two ways. One is an engineer has designed a product. They will send us a SolidWorks drawing, which then we can review with them, make sure if it's optimized, if they want changes, et cetera. That file would then go into the printer and would be, 1 unit, 100 units, or paired with other types of parts. So that's kind of the discussion there with the engineer. The other side is a customer comes to us with a problem. We had a SWAT team reach out the other day. They had a robot that went down. SWAT team didn't have a big budget to buy a new robot, and the tire was broken. So they mailed us their tire. We 3D scanned it, created a SolidWorks model of that part that is now unavailable in the market, put that in our printer, and then basically the printing process started. So it will go through on the metal side, it will go through that kind of inkjet-like process. You'll get a box of powder with products basically submerged within it. That then goes to an oven where it will bake, almost like a ceramic clay inside a nested thing of powder. I call the non-technical term for the next step is the excavation station. We're basically dinosaur digging out these parts. So we're taking an air knife, blowing out the excess powder, One of the really nice things in our process is it's fully recyclable, where if you're machining products, you have a lot of scrap steel that then you're having to deal with. If we're blowing away powder that's not a part, we're recycling that and using that in the next print. So we have very limited wastage. It's 90+% recapture in terms of our materials. And then basically once you blow it out, then you get a ceramic clay, basically, or metallic clay. And we put that in a sintering furnace where it's blasted with different gases at 1300 Celsius, and then we get a finished part out of that.
So it cures like pottery?
Yeah, it's just like ceramics or other things.
And the material that you're able to do this with, it's metal? Is it also, you said wheel, so I think, well, is it rubber or what?
Yeah, so we've got a wide range of materials. Our biggest kind of production line is on the metal side. We have a decent range of materials we can work with. Traditionally, we'll work with stainless steels. A lot of our customers require that. On the plastic side, we have 30+ materials. So right now we made a rubber foot for a robot dog, for example, to making a rigid wheel. So it's a very big range.
Interesting. Yeah, so you founded multiple businesses, and you've been in Houston for a while now, and you've raised over $100 million here in Houston, right? Tell me a little bit about that process and how you went about that.
Yeah, so it really, I think it's a process of persistence, to be frank. So I moved from China in 2017, started my first business out of my garage with a pickup truck.
Here in Houston?
In Houston, up in Cyprus, and I knew no one, right? So it was on me to develop that network. And
Pause for a second, because I want to understand then what made you take that red pill to be an entrepreneur at that point.
Yeah, so for me it was, I always had an entrepreneurial mindset. I built, in my backyard, I think I had 5 vertical feet, but at 12, 13, built a ski resort, built a website for it, built snowmakers in my backyard, right? And just had that itch to be on my own. And so when I was working in China, I started in sports, then went to work in oil and gas, and I had a bunch of different kind of backgrounds in different industries. Went to oil and gas and saw how it very much was a mentality of, if it ain't broke, don't fix it. And I saw opportunities to take things from other industries and apply it in terms of efficiency, digital ordering, et cetera. But I was getting resistance. And so I said, I'm 26, what do I have to lose? I'll move to Houston and start a company. And call it being naive, call it whatever you may, but it really was just, I'm going to bet on myself, and haven't looked past since. So maybe it's a gluttony for pain. I don't know.
Well, you've been successful at it so far with multi-time founder now. And then you started with the back of your pickup truck, and then at some point started a company and then raised $100 million for it.
Yeah, so it really is kind of in that journey, what I thought initially, kind of, because you read about Silicon Valley, you read about this, I thought, you just have a great idea, you can raise $5 million. Great, simple. I'll sit back, launch the website, 0 customers. Okay. Reality hits. No investors interested. So I had to say, well, I need to prove it out. I'm going to take, I heard 100 no's, not going to take that for an answer. First year, drove 4,000 miles a week, just banging on doors in West Texas saying, please give me a chance. They say no, I show up next week. Persistence is the key. And then through that process, keep casting a network and, talk to a VC. Can you introduce me to this person? So the network's evolving and keeping people updated on progress. Eventually, I think they just saw you won't quit, but they saw the tangible results of hard work and putting that in. And so that's when it took about 1.5 years from bootstrapping to the seed round. And then from there on out, it was about every 9 months or so we'd raise another round.
So it was $100 million total over how many rounds?
It was over 5 rounds.
And what company was that?
GoExpedi. So it was a vertically integrated digital kind of supply chain solution. So think Amazon for the industrial industry. Anything that wears out, runs out, or breaks, we would supply through the click of a button.
Interesting. Well, yeah, I think that tenacity is one of the hallmark features of an entrepreneur, right? And just Well, from a lot of careers, right? Whether you're a writer and you get rejected, 24 times, and you look at all the famous writers and they were all rejected multiple times before they actually got their book published, right?
Yeah,
So,
and it's taking that as motivation rather than taking that as, a product market fit of this not working. It's, can I glean some inferences from this that can make me better? And will this motivate me? I think it takes a certain personality to, they either feel restrained in their current job, they feel like, they want to be on their own, they want to prove to themselves they can do it. But I think overarching is tenacity.
Is that company still? Did you sell that company or still?
No, it's still going along. So
Yeah.
still a large shareholder in the business.
Okay, great. Congratulations.
On to the new challenge.
Well, speaking of challenges, what is next for you? How are you forging the future here in Houston?
Yeah, so for me, it's a couple avenues, right? In terms of the business itself evolving, it's very much focused on really bringing large-scale manufacturers into this new age. So that's the first step. Then it's eventually forward deploying machines, taking out any last mile within that. And so really creating a new kind of manufacturing ecosystem. I don't know if we're on 4.0 or 5.0 now, whatever .0 it is, bringing us into that age. So that's kind of on the business side and really elevating the industry. The other kind of two angles, one is I really am focused on building a workforce here and training this level of talent around new emerging technologies. So we're making a lot of active efforts to partner with universities. We host a lot of students and just getting people curious and familiar with the industry, whether they're in middle school, they're in a technical college, or at Rice, right? I think it's important to see and understand. And then last, just kind of a personal thing, is I really am motivated by helping guide entrepreneurs down the path because it's an extremely lonely road. And if you haven't raised venture capital money or others, you don't know how it works. And so I spend a lot of time coaching and working with early stage founders just out of liking doing it. And so helping them understand the process. Because if I remember when I started in 2017, Houston didn't really have a startup scene. There was Station Houston, that was about it. And so now it's been great seeing the emergence. You've gotten some huge companies coming out of Houston now. And I've noticed the shift of people graduating from UT or A&M. Before it was, well, I'll go work for Chevron. That's a great career path. Versus I went to Oregon, everybody said, I'll go work for a startup in Silicon Valley, right? That's starting to shift now that Houston's seeing success and the ecosystem's building. So I want to stay focused on kind of motivating the youth to start a business as well.
Yeah, I mean, we share a similar passion there. Where are you hanging out nowadays to do that mentoring?
Usually it's coffee shops. So for some reason, people find me and just look me up on LinkedIn and would be happy to talk through, tear apart your deck or whatever it may be.
That's great. Well, we'll have to get you into the studio sometime. I think that there would be a lot of founders that would be interested in hearing. And then also this angle of manufacturing isn't a story that I've been hearing very often here in Houston. And I think there is a lot of logistics in manufacturing that does go on here. So, and I think raising that visibility is important. Well, Tim, thanks for everything you're doing for Houston, and congrats on your success. And I'm sure we'll be crossing paths again soon.
Definitely. Really appreciate being on. Thank you.
Sure.